now we're going to go off to still looking at tree diagrams. I'm actually not going to make this tree diagram with you guys. This one is ginormous, and this is where the flaw comes in for making tree diagrams. So now we're looking at two-stage experiments and multi-stage experiments, and that's just dealing with two or more events within, within each scenario, excuse me. So to take a hamburger order, this person asks each customer questions from the script shown. Draw a tree diagram to represent the sample space for the burger order. So if you look at her scenario, she's got three questions: kids, regular, large, cheese or no cheese, and then do you want tomato, yes or no, or pickle, yes or no. So lots of options that could go with this, which means that the tree diagram would get really big really fast. I actually drew it out on my sheet of paper and it took up my entire paper. So again, if you want to look at it, go look at it in your book. You can see just how big it is. With that being said, since tree diagrams can get so big, we're going to look at what's called the fundamental counting principle. And the fundamental counting principle asks you to come up with a number of outcomes for each event and then just multiply them all together. That will get you your entire sample space or your entire possible outcomes. Okay, sounds maybe a little bit more complicated than what it is. So we'll look at an example out of this. Actually, I got three of them down here at the bottom. So let's look at letter A here. The answer shown is complete. So find the number of possible outcomes for each situation. So for 3A, I'm going to look at this answer sheet off to the right here, and I want to know all the possible outcomes for filling in this answer sheet. Well, I look at question one. Question one has four possibilities. So I'm going to say 4 for the first one, times, again, the second one has 4 options, so times another 4. Third question, 4 outcomes, so times another 4. My pen stopped working, give me a sec. There it goes, times another 4, so that's question 3. Question 4, 5, and 6 also have 4 options, so I'm going to do a total of 3 more. 2, 3. So those 4, or all those 4s represent questions 1 through 6. Then for questions 7, 8, and 9, and 10, each one of them has 2 options. So for question 7, we would say we have 2 outcomes for that. For question 8, we have 2 outcomes. Question 9, we have 2 outcomes. And question 10, we have 2 outcomes. Your total possible outcomes come from multiplying all these numbers together. And when you do that, you're going to get 65,536. That would be for letter A. Letter B, a number die is rolled 4 times. Well, on one roll, you have 6 options. On your second roll, you're still going to have 6 options, third and fourth. So if you multiply them all together, you would get 1,296. And then finally, letter C. This one was A, this one was B, and then this one is C. So a pair of women's shoes comes in whole sizes 5 through 11. So coming up with the number of sizes, there are 7 of them. And then once you know that there are 7 sizes, you have how many different colors? 1, 2, 3, 4 colors. So times 4. You can either get them in leather or suede. I think that's the correct pronunciation. I don't know shoes very well. And then they also come in 3 widths. Multiply those all together, there are 168 options for shoes. And that's what the fundamental counting principle looks like.